For this next part, what I would like you to do is I would like you to do an actual experiment. So get some coins and a dice, and I want you to do this experiment. Okay, so we're going to first do a coin flip, and I'll just kind of show you what this should look like, and you're going to then go ahead and do it on your own. So you're just going to generate an experimental probability. Okay, so we have to actually flip coins to get an experimental probability. So our probability of getting heads, our theoretical probability, we should be thinking of it as 1 over 2 or 50%. Okay, so what I want you to do is actually flip some coins. Okay, count the number of heads and tails. So as you get a heads, I'm going to make a mark here. I got a heads, 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 tails, heads, tails, tails, heads, 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 tails, 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 heads. And we're just going to make a tally as we do our experiments. And I want you to do this, well, how many times should we do this before we get an accurate probability? Well, to get the precise probability, we could do it an infinite number of times, but that's impossible. So essentially the idea is that the more times the better. So I want you to do at least 20 flips and do a tally. And then once you've done your tally, I want you to count the frequency. So I have 9 and 6. And then I want you to calculate the probability of heads. So the probability of heads is going to be the number of heads divided by the total number of outcomes. So in this case, I have a total of 15 here. And the probability of tails then would be the number of tails divided by the total number of outcomes. Okay, so now obviously this is not an accurate result because I was just kind of making this up as we went. But this is what I would like you to do. This is what you should end up with. But I want you to actually go ahead and flip some coins and do this. Same with the dice roll. Okay, so this is a dice roll of 2 dice, and you're going to add up the sum. So you're going to roll the dice. Okay, so I got 6 and 1, so I have a 7. So I'm going to make a tally for 7. I roll the dice one more time. I got 4 and 4. So I'm going to make a tally for 8. And I want you to do this at minimum 20 times. And we probably should do more than 20. So probably, if you have the time, I want you to do like maybe 50, even 100 if you have the time to do this. And do a tally chart. And once you do your tally, so let's say my tallies look like this. Okay, I want you to write your frequencies down. Okay, count it up, write your frequencies down here. Okay, dot, 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 dot. And I want you to work out the number of times we're going to actually focus on getting a sum of 7. Okay, so it could be 6 and 1, 4 and 3, 3 and 4, etc. So we want to get the number of 7s and count up add up this frequency, add up this whole line, and this will give us a total number of rolls that you did. Okay, now it doesn't have to be some nice even rolls. If you get nice even rolls, that's nice, but it doesn't have to be. But then taking this ratio, okay, this is our probability ratio. Probability sum of 7. We're going to take the ratio of the number of 7s we got to the number of rolls, and we're going to write our probability. So this is P. This is number of 7s, and this is the total, and we're going to get our probability this way. Okay, so I want you to do these 2 experiments, and then fill out the charts and fill out your results and figure out what your probability here and here was. And we probably have a very good prediction of what this is going to be, but you may not have a prediction of what the total number, what the probability of rolling a 7 when you roll 2 dice. Okay,